Okay, so 4.6 is pretty quick, and you can actually do most of this in your calculator. So let's take a look here. We have the counting rule. The counting rule is what we're going to use to figure out the number of outcomes in an event. So it is how to figure out the number of outcomes in an event. And the basic premise here is that you're going to multiply the events together. So for example, we want to look at here at a fancy restaurant. You have a choice of 4 appetizers, 6 entrees, 3 desserts, and 2 beverages. So how many possible different meals can you make? So how many combinations of this can I make? What you're going to do is you're just going to multiply. So you have 4 times 6 times 3 times 2. So we would just multiply all of those together. And that gives us 144 different combinations that I can make. So there you're just multiplying. Factorial is a little different. So factorial, what we are doing is you are doing the product of integers from n to 1. Okay, so for example, 5 factorial, and this exclamation point is, that means factorial. Okay, so that's what the exclamation point is there for. So 5 with an exclamation point means 5 factorial. It just means 5 times 4 times 3 times 2 times 1. So it's kind of like the 12 days of Christmas. When you see the exclamation point, you're just going in descending order and multiplying. So that would be 120. Now, there is a button in your calculator for this because we could get something that is a lot larger than 5, and then it's a pain in the butt to go in descending order. So that is going to be, so if I want to do 5 factorial, you're going to go in your calculator. You're going to do the number first, so 5, and then you're going to come over here to this button that says math, where my mouse is circling. Then you're going to scroll over. You want to scroll over to PRB for probability. So you can either just go one to the left on your left scroll, or you can scroll over to the right. Okay, so you want to highlight the PRB, and then you're going to pick the exclamation point. So for me, it's the 4th one down, enter, so 5 factorial, and then my calculator will do that. So let's say I wanted to do 20 factorial, 20, math, PRB, exclamation point. Okay, it's a really, really, really big number, so it's in scientific notation. So let me just write this down for you. So you go 5, math, PRB, and then the exclamation point. Okay, let's do one with a smaller number. Maybe we'll do 12. Let's see if that one will. No, let's do 9. 9 factorial. There you go. Okay, so that's 9, 8, 7, 6, 5, 4, 3, 2, 1. Next, we have the combination formula. So combination is when you are selecting, so here's the formula. It goes like this, N, C, R, and it goes n factorial over n minus r factorial and then r factorial. Okay, and this is when you are selecting r from n distinct elements. And in a combination, the order does not matter. Okay, so for example, let's say I want to form a committee of students, and I'm going to pick 3 students out of a total of 20. Okay, so that would be 20 C3. Okay, so plugging that into the formula, so you can do this 2 ways. You can do it in the formula and then you can do it in your calculator. If I'm using the formula, I'm going to go n factorial, so 20 factorial over n minus r, so 20 minus 3 factorial, and then 3 factorial. So basically, it looks like this. Let's see, 20 factorial over 17 factorial, 3 factorial. You can kind of work that out algebraically. I'm going to show you how to do it in your calculator in just a second here, but let me scroll over. Okay, we want to do that algebraically. If you go like this, 20, 19, 18, 17, you can stop at the 17 factorial because the 17 factorial and the 17 factorial are going to cancel each other out. And then you can do 20 times 19 times 18, and then that can be over 3 factorial, which is 3 times 2 times 1. Okay, so you could do that. Let's see. 20 times 19 times 18 over 3 times 2 times 1 is 6, so 1,140. Okay, or you can actually also do this in your calculator. So for 20C3, you're going to go 20, then you're going to go math, same place where we found the factorial, so the exclamation point. So go over to PRB, and then your NCR. So for me, that's the third one down. And then you put your R in, which is 3, and you get 1,140. Okay, so 20, then math, PRB, then select NCR, and then 3, and then enter. Okay, then the last formula we have here is the permutation formula. So the permutation formula is slightly different. Okay, it's NPR, and it's going to look like this: n factorial over just n minus r factorial. Okay, so there's no extra r factorial like there is in the combination formula. Permutation is when we do out of n elements, select an ordering. And then in this one, of course, order will matter. So for this example, let's say you have finals in a track meet, there's 8 people. Well, how many ways could you get first, second, and third? So that's what we mean by selecting and ordering. Okay, so first, second, and third, or maybe something like president, vice president, secretary, that kind of thing. So there's an ordering. So that would be 8 P3 for second and third out of 8 people. So 8 factorial over 8 minus 3 factorial. Okay, and then you can work that out. That's 8 factorial over 5 factorial. Which then we could do 8, 7, 6, 5 factorial, and you can cancel out the 5 factorials. So you get 8 times 7 times 6, 336. Okay, but you can also do this in your calculator, same place you found NCR, you're just going to select the NPR. So 8, then math, scroll over to PRB, select NPR, 3. Okay, so same thing as this. So we go 8, math, PRB, then NPR, 3, and enter. And that's pretty much it for 4.6. We're not really going to go much more than that. So it's pretty simple. So let's finish up chapter 4 with the practice problems. So both classes, we already did the first practice problem. Okay, so we're going to go to the second one. Let me see so I can see everything. I'm just going to zoom out a little bit here. There we go. All right, so using the table below, showing the relative frequency of grades in a certain statistics class to determine the probability, the following probability. So here's how the grades broke down percentage-wise. Okay, and then let's just say for simplicity's sake, there was 100 students. So the 0.20 would represent 20 students, the 0.31, 31 students, etc. Okay. What is the probability that a student chosen at random passed, got an A, a B, or a C? So for this one, for probability, it's or, okay, that they passed. So all we're going to do here is add these probabilities. So you want to add the probability of an A plus the probability of a B plus the probability of a C. So that would be a 0.20 plus 0.31 plus 0.23. Okay, so that would be 0.74. All right, then B, what is the probability that a student chosen at random did not pass? Same thing. So probability of a D plus the probability of an F plus probability of a W. So 0.14 for D, 0.07 for F, 0.05 for a W. So 0.26. Okay, notice that if you add pass and not pass, you get 1. So the other thing that you could have done, the probability the student at random did not pass, is you could do 1 minus the probability of pass. So 1 minus 0.74 would also give you the same probability. So there's more than one way to go about doing part B there. Okay, then you have part C. Given that a student chosen at random passed, what is the probability that they got an A? Okay, so given that the student passed. So given, remember, that is your denominator. So what is the probability that the student passed? Okay, that's your 0.74, which we found in A. Probability the student passed, 0.74. So that's your denominator. So what you're going to do is the probability of an A over the probability that the student passed. So the probability that the student got an A is 0.20. Okay, the probability that the student passed, 0.74. Okay, so 0.20 divided by 0.74 is 0.27. Okay, and if you looked at that, like I said, with simplicity, if you wanted to check the math, okay, given that the student chose an at random pass, what's the probability they got an A? So, for example, if there were 100 students, well, 74 of them passed. Out of those 74, what percentage got an A? Well, 20 of them got an A. 20 divided by 74 would still give you the same thing. Okay, just with the decimals. Sometimes it makes it better to put it in context. So out of 100 students. So 27% of the passing people got A's. All right, the next one we have is, let's see here, the probability that a person is allergic to a certain drug, I'm trying to find this question here, is 0.03. What is the probability that none of 3 randomly selected persons is allergic to this drug? Assume that all 3 persons are independent. Okay, so when the events are independent, what we can do is we can multiply these together. All right, so the probability the person is allergic is 0.03. What is the probability that none is allergic? So we need to find the probability that someone is not allergic to the drug. So this is going to be 1 minus the probability that they're allergic. Okay, so it's 1 minus 0.03. So let's see here. 1 minus, so 0.97. So 97% of people are not allergic to the drug. Okay, so P, not allergic. (0.97). So now we are selecting 3 randomly selected people, and we're independent. Okay, so we're going to go like this. P not allergic times P not allergic times P not allergic. I'm not going to write all that out. So 0.97 times 0.97 times 0.97. Each time I select the person, they have a 97% chance of not being allergic. Okay, they're independent. So that's going to give us 0.91, we'll do 0.913. All right, next problem we have. Of people who died in the United States in a recent year, 86% were white, 12% were black, and 2% were Asians. This ignores a small number of deaths among other races. Diabetes caused 2.8% of the deaths among whites, 4.4% among blacks, and 3.5% among Asians. The probability that a randomly chosen death is a white who died of diabetes is about. All right, so this is, are they mutually exclusive events? So we ask ourselves, can this happen at the same time? Can you be white and die of diabetes? Yes, you can. So these are mutually non-exclusive. Okay, so for mutually non-exclusive events, okay, we have probability of A given B times the probability of B. Okay, so the probability of B is going to be the death of dying of diabetes. Okay, so that's 2.8%. And we're going to want to make these into decimals. Okay, so B is going to be diabetes, and then this is white given diabetes times diabetes of white people. All right, so here's the numbers we're looking at. Of the deaths, 86% were white, but of those 86%, 2.8% were diabetes. So that's your white given diabetes. So what you want to do for that white given diabetes is going to be 0.86 for 86% times 0.028 for diabetes. So it's 2.8% of 86%. So we multiply those. That is going to give us 0.02408. But then we need to take that and multiply it by that diabetes 2.8%. Okay, so the diabetes of deaths of the deaths among whites. Okay, so that's 2.8%. So then take that, multiply by 0.028. So your A given B is this 86% times 2.8%, and then multiply that by B, which is your 2.8%. So that gives us 6.7424e to the negative 4. That's scientific notation. Okay, what that means in scientific notation is this. So let's just do 6.7. Times 10 to the negative 4. That's what the scientific notation is, which basically means I have 6.7. My decimal needs to move left because of the negative sign 4 places. So 1, 2, 3, 4. Fill that in with zeros. So the probability there is 0.00067. All right, now that's how we would approach a problem like that. I'm not going to put a problem like that on the test, but this is something that you might see on like an AP stats exam or worklet, or if you go on to do more stats classes. All right, now we have another table for number 5. Okay, and this is not a two-way table. There's a lot of things on here. So let's take a look. Following table depicts the Nobel Prize winners in some categories by country from 1901 to 1998. All right, so we want to look at this table. We want to answer some of these questions here. So I'm going to want to tally up this table. So I have the tallies for us, but what we basically have here is we've got chemistry, the total number of Nobel Prizes in chemistry. I think if we add this whole column, you're going to have 110. Medicine, you're going to have 144. Physics, 191. If we add all of these across, I think, let me just check that real quick. 445. So there's 445 total awards on this table. And then add the countries across. So France is 43. Germany, 107. Japan, 8. Soviet Union, 18. UK, 71. And US, 198. and then 445 is that total. All right, so let's answer questions now. We have these numbers. If a winner is chosen at random, what is the probability that he or she won their award in physics? So if a winner is chosen at random from the entire pool, so the entire pool is 445, so that's our denominator. How many physics were there? So go to your physics column, all the way down, 191. So 191 out of 445 is going to give us 0.429. Okay, if a winner is chosen at random, what is the probability that he or she is from France? So out of everyone, how many people were from France? You guys can go ahead and type it in if you are keeping up here. How many people from France? 43, yeah, so 43 out of 445 is going to give us 0.09, and we'll run that to a 7. All right, next we have, if a winner is chosen at random, what is the probability that he or she is from the United States, given that the award is won in the field of medicine? So your given is the denominator. The denominator is medicine. So how many total medicine awards were there? There were 70, no, total medicine. 144 total medicine. And then what is the probability that he or she is from the United States? How many people in the United States got a Peace Prize in medicine? So we're going to go up to the table. Medicine, United States, right here, 82. Yeah, 82 right there. So 82 US people that won medicine, and then total medicine. So 82 out of the 144 were from the US. That is 0.569. Okay, then flip that. If a winner is chosen at random, what's the probability he or she won in medicine, given they're from the United States? So now the US is your denominator. How many total prizes from the US were there? $198, yeah, so 198 from the US. Okay, out of that, how many were medicine? Same as the above numerator. 82. So 82 out of 198. 0.414. And then E, if a winner is chosen at random, what is the probability that he or she won the award in physics or chemistry, given that he or she is from the Soviet Union? Okay, so let's take a look at this. So first, the given the Soviet Union. Soviet Union, total of 18. Okay, and then it was physics and chemistry. So you had 10 physics, 7 chemistry. So here's what we're looking at. You've got physics. There were 10 out of the 18 from the Soviet Union. Okay, plus chemistry. There were 7 out of the 18 from the Soviet Union. So 10 over 18 plus 7 over 18 is 17 over 18, which is almost 100%. So 0.944. Okay, so with the word or, you're just adding. All right, and then next question, let's see what we have here. A simple random sample, oh, this cut off. All right. Did it cut off on your guys' handout? No? Okay, good. So you can see the questions. All right. All right, so a simple random sample of adults living in a suburb of a large city was selected. The age and annual income of each adult in the sample were recorded. Resulting data are summarized in the table below. So, well, we got to kind of fix this a little bit, at least at the edge here. So you got your totals. Let's see, what was this? This was 50, 89, 53, 15, and 207. So there were 207 total that were surveyed. Okay, so A, what is the probability that a person chosen at random from the sample will be in the 31 to 45 category? So P, I'm just going to put this down here, 31 to 45. Okay, so how many people were in the 31 to 45 age group? Here's my 31 to 45. So total 89. So 89 out of 207. So 0.430. All right, B. What is the probability that a person chosen at random from those in the sample whose incomes are over 50,000 will be in the 31 to 45 age group? So here you want to look at, okay, so the probability that you are over, 31 to 45, given your income is over 50K. Okay, so that's what we're looking at here. Probability that out of those whose incomes are over 50,000, they are in this age group. So over 50,000, we're looking down, so that's 96. So out of the 96 people whose incomes are over 50,000, how many are in this 31 to 45 age group? We're looking here. So out of these 96, there were 35 here. So 35 out of 96. So 0.365. And then based on your answers to parts A and B is the annual income independent of age category for those in this sample. Okay, so the answer to this for independent, you want to compare the probabilities. So we have 0.430 is not equal to 0.365. So because the probabilities are not equal, they are not independent. No, because probabilities are not equal. And that's it. The next thing we go to is chapter 5, which is probability distributions. But I want to give you guys some time with just the probability. Chapter 5, I think, is actually easier than chapter 4, so you can look forward to that. But for this week, for your homework, you're going to want to do the chapter 4 homework and the chapter 4 quiz. So make sure you spend some time in that, get a good grasp of it. And then on Tuesday and Wednesday, depending on which class you're in, we will take a look at chapter 5.